Today we are going to discuss about lexical analyzer generator. Lexical analyzer generator is a Lex tool. Before seeing that lexical analyzer generator, we'll see the how the transition diagram is implemented, and then we'll see the structure of Lex program, then some of the examples, then structure of YAG program and example. First, let us see implementation of transition diagram. In the last class, we have discussed about the transition diagram of various tokens like relational operators, unsigned numbers, identifiers, etc. So now we will see how to convert the transition diagram into program. So for that, what is the aim of that our program, our transition diagram? It has to return the token. So the return type of the, here we have taken the function get relational operator. That function return type is token. So token, we have taken the get relational operator. So that is the return type of the function. Then next is we have taken the get return token also. That variable type is token, and it will return the new relational operator. New is the operator used to define that. Then switch, we have used the switch case statement. Switch, the state is given as an input. So here how many states we are having? 0 to 8. So we will be having cases case 0 to case 8. Then each state it reads some input statement. For example, case 0. So it will read the character. It reads 3 characters. Either it may read less than or equal to or greater than. So using the next char function, we have read that thing and it will be stored in C. So C equal to next char. So now that C may be less than, equal to or greater than. If C equal to less than means it will go to the next state 1. So that's the thing. If C equal to 1, it will go to state 1. Else if C equal to, if it is equal to mean it goes to the state 5. If C is equal to greater than means it goes to the state 6. Otherwise it fails. Other than it, less than, greater than or equal to character to leads mean that is fails. Here we are not specified any of the states transition here. Then same thing, if we'll go for the next state case 1, we will take what will happen. Then first statement will be C equal to next char. The next char may be from state 1, it will be equal to or greater than or other. So if C is equal to means what will happen? Goes to the state 2 and it will return the token. Return token dot attribute equal to, what is this? Less than equal to. Less than or equal to, it will return the token. Then again, otherwise it will read the character greater than. If it reads the greater than symbol, it goes to the state 3 and it returns the token. Return token dot attribute equal to not equal to. And if it reads the character other than that anything else what will happen? It goes to the state 4 and it retract and then retract to the state 1. Retract means it will go to the previous state. So 1 it will come, it will return the token less than. So like that it is going to work out. And then the case 8 will take means, suppose there is a case 2, case 3, case 4, 5, 7, 8. All are final states. In that final states, case 2, 3, 5, 7, these things are there. In these states there is no backtracking. Retracking is not there in these states. So suppose if equal to 5 means return the token relational operator equal to. If 7 means return the token relational operator greater than equal to. But if it is state 4, case 4 means what it has to do, it has to retract and then return token dot attribute equal to less than, it will return. Then return token. Same thing for if it is case 8 means it will retract, then it will return token dot attribute equal to greater than. And then this, like this it is going to work out. Then finally the output will be in a token. So our aim of this transition diagram is, this program code is get the token, what token it is going to return. Same way you can take the transition diagram of unsigned number or the transition diagram of relational operator. Relational operator already we did. You need to write the complete code of all the cases. Or you can take the transition diagram of identifiers. You can try to convert into program. So that is the thing. So everyone understood this, the implementation of transition diagram. Next we'll move to the next topic, lexical analyzer generator. So the lexical analyzer role is how to convert the role is converting the sequence of programs statement into tokens. Tokens are already we know the basic unit of a program. The token may be a identifier, or it may be a keyword, or it may be a relational operator, or constants, or it may be a special characters, and so on. So then after returning the token, how the transition diagram will be implemented means, that is implementation of transition diagram. Arrange for the transition diagrams for each token to be tried sequentially. So all the transition diagrams will be arranged sequentially, then run the transition diagrams in parallel. That means all transition diagrams are executed in parallelly, and then combine all transition diagrams into one. Finally all the transition diagrams will be combined into one. Suppose in that having some 10 tokens it is going to return in the program, all 10 will run parallelly, and finally all 10 transition diagrams are combined into one. So next we will see the structure of Lex program. So before seeing the structure of Lex program, first we will should know what is Lex. Lex is a lexical analyzer generator. It is a tool used to generate the tokens. So what the tool is going to do, it will take the source program as an input, and it will convert that into stream of tokens. So in this Lex only you are going to use in your lab also. In the lab I think we are having Lex and Yak programs. And Yak also, you know, already we have seen in the introduction part of the compiler. We have the different phase of the compiler, that is 6 phases are there. The first phase is lexical analyzer. Lexical analyzer, the built-in tool used is Lex. Next phase is syntax analyzer. Here the built-in tool used is Yak. Then next we are having semantic analyzer, intermediate code generator, code optimizer, and code generator. So now we'll see Lex. So how that Lex tool it is going to work. Before that we'll see the structure of Lex program. Like C program means everyone knows what are the things are there in a C program. Initially we are having a declaration. Then after declaration we are having a, in the declaration part itself we can give the header files, and if we want to define any macros we can give like hash define pi 3.14, that and all we can give. Global declarations we can made it over there. Then next we want any command lines, we can specify the command lines. And command lines also you people knows, the single line command means double slash, multi-line command means slash star star slash, and then after that we'll be having a main program. Then within the main program also we may be having, we are having the declaration. First it will opening brace, within that we are having declaration, then input output statement, input statement output statement, then operation to be performed. Again we may use a set of one or more functions, and so on. So this is the structure of the C program. Like that the Lex program also having the structure. Initially the declaration part will be there. Then next the translation rules. After declarations the translation rules part will be there. Then auxiliary function. So in the declaration part it will starts with percentage opening bracket. Then you should give all the declaration. The declaration should be in a C language. We'll give, in suppose for example our aim is count the number of vowels and consonants of a program, means here we want to count how many vowels are there, how many consonants are there. So for both we are going to use one variable. So we can give int vowel is equal to, initially we want vowels, int vowels we can give, or we want to initialize that vowel variable as 0 initially, means you can give int vowel equal to 0, int consonant equal to 0. Then any header file, suppose we are using in the subroutine part some that input output statement, printf, scanf, anything, means we have to include the header file hash include stdio.h. So these statements are pure C statements. In the declaration part what we are giving between percentage opening bracket percentage closing bracket is full pure C statement. Then next it starts with the percentage, and then we are going to give the translation rules, then ends with percentage. So the rules part is given between percentage symbol, double percentage symbol. So the translation rules part contains two parts, pattern and action. Pattern means what is the operation to be performed. That pattern we should specify with the regular expressions. Already we have discussed regular expression. Now I think you understood why we have discussed regular expressions in the previous topic. So what is the regular expression? It is used to specify the pattern. To specify the pattern only we have discussed about regular expression. So we